So today we're going to look at problem 3.10, which is to consider a spin 1/2 particle with some magnetic moment. And at times t equals 0, the state of that particle is spin up in the z direction. The system is allowed to evolve under a uniform magnetic field, which points equally in the x and z hat directions. What is the probability that the particle will be measured to have spin down in the z direction after some time t? All right, so we would like to know what is the probability of it starting in the spin up state and then later being measured in the spin down state. This is equal to the probability of measuring it in the spin down state and its overlap with psi of t, whatever that is, squared. So let's work through the examples that we have. We want to write psi of t. So to do that, we need to start with psi of 0 and write it in terms of the energy eigenstates. So we want to we start by writing psi of 0 in the energy eigenstates. But what are the energy eigenstates? Let's start by diagonalizing the Hamiltonian, that is finding the eigenvalues and eigenstates. And from there, we will then figure out what all this is going on. So let's look at the Hamiltonian, which remember is minus the magnetic moment mu dotted into the magnetic field B. We were given mu last time. We learned that there were some minus signs that canceled and we ended up with E over m sub E, the spin dotted into the magnetic field. So remember, this is E over m sub E, the spin dotted into the magnetic field. The magnetic field here was B naught over the square root of 2 x hat plus B naught over the square root of 2 z hat. So dotting into this, I will get E over m sub E. I will get Sx times B naught over the square root of 2 plus Sz B naught over the square root of 2. Since B naught over the square root of 2 appears everywhere, I'm going to factor that out so that I have E over m sub E, B naught over the square root of 2. And then I get Sx plus Sz. So I know what these are, which is, a good thing. And what I am going to do is, first let us define omega naught as equal to E B naught over m sub E, just like we did in problem, 314. So this then, the Hamiltonian becomes omega naught over the square root of 2. And then I'm going to add Sx, which is h bar over 2, 0, 1, 1, 0, plus Sz, which is h bar over 2, 1, 0, 0, minus 1. Again, the h bar over 2 factors out, from which there is much rejoicing, as there always is with factoring. Omega naught h bar over 2 square root of 2. And then I get 1, 1, 1, minus 1. This is my Hamiltonian here. All right, let's find the eigenvalues and eigenvectors. So I start by finding the Hamiltonian minus lambda times the identity matrix. This becomes omega naught h bar over 2 square root of 2 minus lambda. omega naught h bar over 2 square root of 2, omega naught h bar over 2 square root of 2, omega naught h bar 2 square root of 2, it's a minus sign there, minus lambda. And I am next going to take the determinant of this mess, the determinant of h minus lambda I, and this becomes omega naught h bar over 2 square root of 2 minus lambda times minus omega naught h bar over 2 square root of 2 minus lambda minus omega naught h bar over 2 square root of 2 quantity squared. So going back up the diagonal that way. So I can, and I need this to be equal to 0 in order for this matrix to be singular so that I have a non-trivial solution. So I can then solve this as 0 equals minus omega naught h bar over 2 square root of 2. This becomes this quantity squared. And then I'm going to multiply out so that I have, I'm going to do the very fancy trick of, so this is looking at these two squared. Then I'm going to multiply this one times this. I'll get a plus sign lambda omega naught h bar over 2 square root of 2. Then I have the minus omega naught h bar over 2 square root of 2 times lambda plus lambda squared minus omega naught h bar over 2 square root of 2 quantity squared. So there is, of course, some fantastic happy rejoicing because I am going to now cancel things, which is, of course, my favorite part in math, right? All right, and then I can write this as lambda squared minus 2 omega naught h bar over 2 square root of 2 quantity squared, or lambda squared equals 2 omega naught h bar over 2 square root of 2 quantity squared. And I am going to take the square root of both sides so that lambda equals plus or minus the square root of 2 omega naught h bar over 2 square root of 2. More excited canceling. And I am left with plus or minus omega naught h bar over 2. These are my values of lambda, which I am going to point out are the same values that we had in the previous example problem, except that, of course, my directions are going to be different. They are now, I now know that my Hamiltonian is proportional to S sub n, where the spin is along a different direction, the S sub n direction, but it still has spin up or spin down along that direction. And if I look at my coordinate system, my X, Y, Z coordinate system, spin sub n is in this direction. So if this is B naught, then I have B naught over the square root of 2 here, and B naught over the square root of 2 along this direction. So this means that they're equal. So that means this angle here should be 45 degrees, which is theta equals 45 degrees, or 90 degrees, pi over 2 divided by 2, so pi over 4. And phi is along the x-axis, so phi will be equal to 0 because there's no y component. All right, so I'm just going to go ahead and plug this into my generic term, which was on page 42. So rather than solving for the eigenvectors, I'm going to say, well, obviously this is proportional to Sn. I know what the angles are. I'm just going to take the value and save myself some time. So this is up, spin up in the n hat direction. This is going to be the cosine of theta over 2. So that's pi over 4 over 2, which is pi over 8. Spin up in the z direction, plus the sine of pi over 8. Spin down. e to the I phi, but phi was 0, so that's just 1, so I can ignore that, which is fantastic. Spin down in the n hat direction. This is the sine of theta over 2, so the sine of pi over 8. Spin up in the z direction, minus the cosine of pi over 8. Spin down in the z hat direction. And so these here are my energy eigenstates. So I need to write psi 0 in terms of this mess. Oops. Let's go back down to our regular size. So I want to look at psi 0, and I want to write it in terms of the energy eigenstates. It's going to start in the z hat direction. And I can use the old multiply by 1 trick. So multiply by the identity matrix. And remember that the identity matrix was those projection operators, plus in the n hat direction, n hat plus this minus in the n hat direction, times still this plus direction. So this becomes then spin up in the n hat direction times the inner product of spin up with spin up in the z direction, plus the part that is spin down in the n hat direction, n hat spin down inner product with the plus. So again, psi of 0 is equal to this overlap of n plus with the plus sign, which if I go back up, n hat with the plus is just going to be this position, sorry. So I can write this as the cosine of pi over 8 n plus hat, plus then I want, so this part, that is this term. And then I also want to look at this portion, which is going to be this term. So this also then becomes the sine of pi over 8 minus n hat. So now we have the starting state in terms of the energy eigenstates, for which there is, of course, much rejoicing. So now let us find psi of t by simply including our multiple, our e to the I stuff in term multiplied by our coefficients. So I have cosine of pi over 8 times e to the minus I, the energy of the plus state, time over h bar, times plus in the n hat direction, plus the sine of pi over 8, e to the minus I, energy of spin down, times t over h bar in the minus n hat direction. Again, more rejoicing. But I remember what these energies are because, you know, I just looked them up, or I just found them. So I can then look at these. These are minus I, and this was omega naught h bar over 2, t over h bar, spin up, plus the sine of pi over 8, e to the minus I, minus omega naught h bar over 2, t over h bar, spin down in the n hat direction. So let's do some excited canceling again. We're going to cancel the h bars. Hooray! And I'm going to go ahead and cancel this minus sign while I'm at it, just because, you know, I do get a little excited with the canceling of things. So this becomes the cosine of pi over 8 times e to the minus I omega naught t over 2 times the plus in the n hat direction, plus the sine of pi over 8 e to the plus I omega t over 2, spin down in the n hat direction. All right, we're going to do the old trick where we factor things out front. So to do that, what I want to do is factor out this term e to the minus I omega naught t. So I have cosine pi over 8 e to the minus I omega naught t over 2 plus n plus the sine of pi over 8 e to the plus I omega naught t over 2. I'm going to do the fancy add 0 trick here, where I go plus I omega naught t over 2 minus I omega naught t over 2. This, along with the multiply by 1 trick, are incredibly useful. So this, I am going to keep these two together, and this is the one that I will factor out. So I then have e to the minus I omega naught t over 2 times the following mess. The cosine of pi over 8 in the spin up direction, in hat direction, times the sine of pi over 8 e to the I omega naught t times spin down in the in hat direction. This is psi as a function of time. All right. So this is in its most useful form. I will now find the probability of measuring spin down after starting in the spin up direction. So remember we said that was spin down overlap with psi of t quantity squared. So I am going to put this, multiply this whole thing out. This becomes minus the minus bra and the z hat direction times, times e to the minus I omega naught t over 2 times the following mess, cosine of pi over 8 spin up in the in hat direction plus the sine of pi over 8 spin up times e to the I omega t spin down in the in hat direction, quantity squared. So this gives me e to the minus I omega naught t over 2, which I'm about to square and tell you is not physically significant. And then this gets multiplied by the cosine of pi over 8 times spin down times spin up in the in hat direction, plus the sine of pi over 8 e to the I omega naught t spin down times spin down in the in hat direction. All this squared. So this probability of plus then being seen as a minus, let's make sure I wrote all this, sorry. So looking at this, I can see that this term, e to the minus I omega naught t over 2, if I square it, I then take the complex conjugate, this times its complex conjugate, that gives me 1. And then I'm going to square this cosine of pi over 8, this overlap of the negative z direction times positive in hat. And that, if you go back and look it up, is just sine of pi over 8 plus the sine of pi over 8 e to the I omega naught t times the overlap of spin down and spin down in the in hat direction. This is cosine pi over 8. Quantity squared. Well, then there's still more rejoicing. Woohoo! Okay, I think I picked up a negative sign here. Should be a negative sign. Yeah, there's a negative sign in front of this one. There we go. Okay, so looking at this first one becomes e to the minus I omega naught t over 2 times e to the plus I omega naught t over 2, and that just becomes 1, times then the sine of pi over 8 times cosine pi over 8 times 1 minus e to the I omega naught t, quantity squared. Just say, fantastic, sounds entirely reasonable to me. So this is then equal to these sine of pi over 8, cosine pi over 8. They're just real numbers, so they come right out. Nothing exciting happens. And then I get 1 minus e to the I omega naught t times its complex conjugate, 1 minus e to the minus I omega naught t. So keep going. This then gives me, looking at this sine of pi over 8 times the cosine of pi over 8, I remember that if I look back at my trig identities, I remember that the sine of A times the cosine of A is equal to, well, 2 times this is equal to the sine of 2A. So I can use that part here. And I get 1/2 times the sine of 2 times pi over 8, which is pi over 4, quantity squared. Now I'm going to multiply this out, so I get 1 minus e to the minus I omega naught t minus e to the plus I omega naught t plus 1. So this gives me 1/4 times the sine squared of pi over 4. And then this becomes 2 minus e to the I omega naught t minus plus e to the minus I omega naught t. So we're still looking at the probability of starting in the plus state and then later measuring it in the minus state, which is going to be a function of time. So this is 1/4. What is the sine of pi over 4? The sine of pi over 4 is 1 over the square root of 2, quantity squared. And this becomes 2 minus, now remember e to the I stuff plus e to the minus I stuff. This is 2 cosine omega naught t. So this means that I will start with 1/4 times 1/2 after I square it. I'm going to bring out the other 2 and I get 1 minus the cosine of omega naught t here. I say, okay, that's lovely. One thing I do know is that if I look, okay, just a sec. Okay, so one thing I do know about useful trig identities is that 1/2 minus 1/2 times the cosine of A, I'm sorry, 2A, is equal to the sine squared of A. So I'm going to factor out this 1/2. This becomes 1 minus the cosine of 2A. This equals 2 times sine squared A. So in this case, 2A is equal to omega naught t. So A is equal to omega naught t over 2. And this 1 minus cosine 2A, so 1 minus the cosine of omega naught t is equal to 2 times the sine squared of omega naught t over 2. So remember, again, I'm looking up trig identities. I didn't memorize all of these trig identities. I just know that they're there. So these 2 cancel, and I am left with 1/4 times, now plugging in for the trig identity here, this is 2 times the sine squared of omega naught t over 2. To say, okay, that's nice. What happened to my notes? Oh, there they are. And then this 2 cancels one of these. And so I am left with the probability of starting in a plus state and later measuring it as a minus state of 1/2 sine squared omega naught t over 2. This is the final answer. This is an example of Robbie's formula. More about this later. But if you look at this probability as a function of time, t, here's the probability of starting in the plus state, later seeing minus. At t equals 0, let's do this in a different color. How about blue? It's going to be 0. At some later time, it's going to go up to 1. And it's squared, so it always stays positive between 0 and 1. And then it's going to oscillate back and forth like this. All right, so when it gets to 1, that's when the inside has to be equal to what? Pi over 2, right? That would be right. So this would be, this point would be omega naught t over 2 equals pi over 2, or t equals pi over omega naught. Yeah, that makes sense. On this would be 2 pi divided by omega naught. Then like 3 pi. No. Arg. The brains, they don't work. All right. I think that's right though. Okay, so we will stop here. This is the end of the example of 310.